Hello everyone and welcome to day 6, continuing with complex numbers, the idea of an imaginary number. Just as a reminder that a complex number can be written as a plus bi, and that the square root of -1 is equal to I, or I squared is equal to -1. So just remember that square root of -1 equals I. Now, today we're going to be talking about adding and subtracting, multiplying and dividing complex numbers. It's very, very straightforward. If you remember that the square root of -1 is I, that I squared equals -1. And can you do this? If I gave you 5 plus 3x subtracted from 2 plus 1x, can you do that? Well, I hope you can. I hope you can distribute -2 to get -2 minus 1x. And then keep the first factor. And then let's add them. 5 minus 2 equals positive 3. 3x minus 1x is 2x. If you can do that, you can do the beginning of this lesson just fine. And so let's look at this. We're not going to do all of these today. I'm just going to look at a few. So right now we're going to do A and C. Common terms: -2, 6. Those are the real numbers. So -2 plus 6 is 4. 7i plus 2i gives you positive 9i. You are done. Let's look at C. Distribute the negative first, so you get -2 plus 7i. So 5 minus 2 is 3. 3i plus 7i gives you 10i. The sum for exercise number 2, 6 minus 8 gives you -2. 2i minus 5i gives you -3i. And there you go. I'm going to look at the more difficult ones here. You guys can practice the other ones by all means, but we're going to look at the more difficult ones here. From last class, if you remember, we can split up the square root of -81 as the square root of -1 and square root of 81. Same thing here, square root of 36, square root of -1. I can now rewrite this. Square root of 81 is 9. Square root of -1 is I. Plus square root of 36, 6. Square root of -1, I. And now I'm going to add them. -30 and 27 is -3. -9i plus 6i is -3i. And there's your answer. Now down to a little more difficult one, where you have to actually simplify the radicals. So square root is -72. Well, we know we're going to have a square root of -1 at the end. But what are we left with? Well, 36 can go into square root of 72. So we're going to get 36 square root of 2, square root of 36 square root of 2, square root of -1. Same thing with 8. We're going to do square root of 4, square root of 2, square root of -1. I'm going to rewrite this as 10 minus the square root of 36 is 6, square root of -1 is I, square root of 2, plus 8 plus square root of 4 is 2, square root of -1 is I, square root of 2. Now, you may be wondering, why did I not write it as 6 square root of 2 and then I afterwards? Good question. The reason I always write I next to the 6 and the 2 here is it goes in front of the square root there. That way you never know if the I, you always know the I is not underneath the radical. So, could have you written it as this? The answer is yes, but I always like to bring this I out in front of the radical so that you understand that it's never underneath the radical. It could all, if you extended that square root, it would have been wrong. And so therefore we don't do that and just bring it out in front. And therefore we get 10 plus 8, that gives us 18. -6i and positive 2i gives you -4i square roots of 2. And hopefully you guys can see that you have the same radical and therefore you can combine them. Simplifying radicals will be on the midterm, very important part of it. Let's see here. Let's look at this middle one right here. We've got to distribute the negatives. We're going to get -11 plus 3i minus 6 plus 4i. We'll get here -17 and positive 7i. So just make sure we know how to do that. One thing that I wanted to look at was this middle box here. It's a subtract from. When you see subtract from, you need to understand that we're going to do 100 plus 7i and subtract it from the 13 minus 2i. You need parentheses. We will then get 100 plus 7i minus 13 plus 2i. I know this is not necessarily the distribute the negative. It's a little sloppy here. We're going to get 87 here plus 9i as our answer. So hopefully that is straightforward. If you do not understand that, please, please, please come and see me. Now, going on to multiplying complex numbers, it's the exact idea that we had talked about here, and this is a book's way of saying it. Think if you were given the complex number as a linear function, so 3 plus 2x times 4 plus 7x. Again, it's the same thing I did at the very beginning. I replaced the i's with x's. You get 12 plus 21x plus 8x plus 14x squared. You can always combine those, so you can get 12 plus 29x plus 14x squared. And the idea that I stated in the beginning, that the square root of negative 1 equals I, and that I squared equals negative 1. That's where this is going to come into play. If I replace the i's with x squareds, so if I did 12 plus 29i plus 14i squared, what we need to understand is that this I squared becomes negative 1. And it now negates that 14. So I'm really going to get 12 minus 14 to get negative 2 plus 29i. And that would be the final answer to that one. It is in standard complex form, a plus bi form, so we did write the product in standard complex form. That's what we did in B. So the idea here is that when you have I times I, the actual value is negative 1. So we're going to do a few of these here. Notice that these are called conjugates. If I double distribute, I'm going to draw the lines for the first couple and not for the last few. 3 times 3 is 9. 3 times negative 5, negative 15i. 5i times 3 is plus 15i. And 5i times negative 5i is negative 25i squared. You will notice that our terms in the middle, because they're conjugates, cancel out. So I'm left with 9 minus 25 times negative 1. Notice that this, again, is the I squared portion. Becomes negative 1. Negative and a negative create a positive. I'm left with 34. When you have conjugates, you will always, the middle two terms will cancel out. In this case, the i's, and we're left with just a real number. If you want it in a plus bi form, though, you need to put plus 0i. If it asks for a plus bi form, it needs to have 0i. The Regents does this a lot to you. If you don't write that 0i, they would take off, unfortunately. So let's look at this one. 8 times 7, 56. 8 times negative 3i, negative 24i. 9i times 7 plus 63, 63i. 9i times negative 3i minus 27i squared. So I'm going to get 56, negative 24, and 63 gives us positive 39i. Negative 27 and I squared gives us negative 27 times negative 1. Notice that the negative and negative create a positive, so I'm going to have 56 plus 27. That gives us a nice number of 83 plus 39i. So this really created, if you want to see where this came from, I made that to a positive 27. Let's go straight down. Let's go right to the next one. It's here. We got squared. Therefore, we need to write it out twice. You do not, let me repeat, you do not ever, Write that down. Do not ever write this as 4 plus 25i squared. You will always get it wrong. Please do not do that. You always have to expand. So 2 times 2, 4, 2 times 5i plus 10i. 5 times 5i times 2 plus 10i. And 5i times 5i plus 25i squared. We get 4 plus 20i, knowing that the I squared makes that a negative 1. You get plus 25 times negative 1. You get 4 minus 25, you get negative 21 plus 20i. Very equal signs there. Again, all of these are in a plus bi form. Okay. Let's go to this last one here. Actually, no, let's do the middle one. 4 times 3 is 12. 4 times negative 4i, negative 16i. Negative 3 times 3, negative 9i. Negative 3i times negative 4i gives you a positive 12i squared. Notice here we have 12. Negative 16 and negative 9 gives you negative 25i. And this is going to actually give us minus 12. Notice that the I squared becomes negative 1. Well, these two terms cancel out. We're left with just negative 25i. But again, writing it as that would be wrong. You have to write it in a plus bi form, so therefore you need to put this 0 out in front. So we're going to leave it at that. To recap, to add and subtract, all we're doing is distributing the negative if need be and making sure that you combine the like terms, real numbers and with the and only the imaginary numbers. Moving on, and then multiplying by expanding. You must expand. You do not just get to square something. And remembering that I squared is negative 1. With that, I will see you in class to finish up the rest of the notes on the last page. See ya.